In this problem, part A, we're given x equals 1, and they want us to find the line tangent to the graph of y equals f of x when x equals 1. So this equation should be popping up in your head because it helps us find y equals mx plus b, which is just a straight line, which is what the tangent line would be. So here we have y minus y1 equals mx minus 1, and you may be asking why x minus 1, but because when you solve that out, it's x equals 1, which was our given. Well then, if you look at the highlighted portion, you see that when x equals 1, y equals 2. Hence, f of 1 equals 2. So we know that y minus 2 is equal to slope m x minus 1. Well, now you're going to wonder, how do we find slope? Well, if you remember, the derivative dy dx is slope. So we can simply use x times y cubed, which is 1 times 2 cubed, which is just 8. 2 times 2 times 2 is 8. Alright. So y minus 2 is equal to 8 times x minus 1, which is 8x minus 8. Y minus 2. Y is equal to 8x minus 6. That would be part A. Now question B is asking us to use that equation we just got to find the approximation of x equals 1.1 and find y. So y is around 2.8. Alright. So that's just part 1, or step 1 for part B. Now step 2 is asking us to use this approximation and figure out if it is greater than or less than the actual y of the original function at x equals 1.1. So now to figure this out, you're going to have to use the second derivative, d squared y over dx squared, or simply f double prime of x. Now, you remember, or you have to remember this, not if you remember, that this can change the concavity. Alright, if it's less than 0, it's concave down. If it's greater than 0, it's concave up. Now when we plug in f of 1 is equal to 2 for the second derivative, we get 8 1 plus 3 times 1 times 4, as given in this picture. Alright, let's move that down here. This would just be 8 times 13, which equals 104. And this is positive and greater than 0. So f double prime of x is greater than 0, making it concave up, increasing at an increasing rate, meaning that our line is going to have to be like this, making it less than an underestimate. Alright, and obviously you'd have to clean this up a little better in the AP test, but I'm just kind of showing the general overview of this problem and how you would go about attacking it. Now for part C, it wants us to find the particular solution if y equals f of x with the initial conditions f of 1 equals 2, so x equals 1, y equals 2. Alright, so dy dx is equal to x y cubed. You have to separate the values. All the y's go here with dy and all the x's go here with dx. We'll multiply out dx and you're going to divide y cubed. This gets rid of this, and we're left with x dx is equal to y negative 3 dy. Now we can start taking the integral of this, and we get y negative 2 times negative 1/2 is equal to x 1 plus 1 over 1 plus 1 x squared over 2 plus c. Now you're gonna ask, why don't we have a plus c here? Well, we do technically, but if you just get rid of it and put it here, we still just have an overall constant. So that's why we don't bother to put it with the y, we just move it over here. Alright, so we are given this so far. Now this would be a general solution, but it's asking for a particular solution, so we need to find this constant with the initial conditions. So if you remember, it was y equals 2, x equals 1. 2 squared is equal to 1 squared, which is just 1, plus c, which is just 4/8. Negative 1 over 2 times 4 equals negative 1/8. Plus c, subtract 4/8 from here, you get that c equals negative 5/8. And now we have to plug this in to our original equation. Alright, now let's start simplifying to just get y by itself. We're going to multiply negative 2 we get y squared is equal to negative x squared, and that positive times negative makes it a negative. Negative times negative makes it positive. 8 divided by 2 is 4. Alright, so this is what we have so far. Now where was I? Alright, so from here we have this, right? I don't know why I didn't just leave it like that. It makes the whole equation a little different. There we go, because this times that, and then we move that in the bottom to make it positive. Alright, so here we have negative x squared plus 5/4. Well, if you want to get sorry, I ran out of space, I don't even know why, but you would simply just multiply 4 for here, let's pretend there's 1 there, times 4 here. And since they have the same base, because that's what we wanted to do, is have the same base, we get 5 minus 4, because that 4 is going to the 1 in front of here, x squared, all over the same base of 4. We're going to take the exponent of negative 1, we get y squared is equal to 4. We have to take the square root of numerator and denominator. We get y is equal to square root of 4 is 2 over, and we can't take the square root of this because there's a negative. 5 minus 4x squared. That, ladies and gentlemen, is part A, B, and C.